can't hear me, please do let me know. No worries. Okay, thanks for joining. All right. Today, this evening, we're gonna cover regression. I believe that's learning unit 4. All right. So let me share my screen and take it from there. Give me a second. All right. Can you just let me know if you can see the whiteboard? So the whiteboard has a table on the left with people's names in the first column. Yes, fantastic. All right, so let's get back there. All right, so today's session, even though you all, you will be tested on it, it's going to be in your assignments and your exam. This is a section that's very widely used in the real world. So it is very useful to actually understand it, because you may use it in your work or somewhere else. And it's basically about making predictions. Okay, that's essentially it, and we do it mathematically. All right, so what I'm going to do is I'm going to illustrate this with some data, which is what you have on this table on the left. Okay, so in the exam and in the assignment and even the real world, what happens is you're only presented with two variables. Okay, so let me just pen working. All right. So you'd be given these three columns, this first three columns here, what I'm underlining in blue. All right. Now, what they're telling you is basically this data, for instance, tells you that Jill has 52 months of experience and her annual salary is 381,000. All right. Sarah has 63 months of experience and her annual salary is 442,000, etc. All the way to Ethan, who has 77 months of experience and earns 610,000 per annum. All right, so what you'll notice, maybe just by visually, so just by looking at the numbers in this table, right, you'll notice that as their months of experience increases, the more experience it has, the higher the salary tends to be. So what we could do is we could plot that. Okay, so this first point that you see here, what I'm going to circle here in blue. Okay, this point here, that's Jill. That's Jill's months of experience on the x-axis. Okay, that's 52, and then on the y-axis, it's showing that it's 381,000 per annum, and we do that for all of them. All right, so Jill all the way to Ethan. All right, so there's about 1, 2, 3, 4, 5, 6. There's 7 of them. There's 7 data points. So we map those points on this graph. All right, and then what you can notice just by looking at the dots, you'll see that as your month's experience increases, the annual salary increases. So the line goes upward. It slopes upward. It has a positive slope. Right. So there is some degree of high school mathematics in terms of gradient and intercept, but don't worry too much about that now. I'll explain that in a second. So what you need to understand for now is that it slopes upwards. So there's a positive slope. That means as your x increases, your y increases. But in this problem, your x is your months of experience and your y is your annual salary. All right. And that's what it's telling you. So let me just stop there for a second. Does everyone understand what I just said now in terms of the graph and basically how to understand this data? Fantastic. All right, great. Thank you. I always appreciate the feedback. All right. Now, what we want to do is we want to try and fit a line to this data. Okay. And to do that, then let's look at it this way, right? I'm going to put a couple of different lines here. Let's put this red one first. So maybe I say that this red line would be the best to fit this data, okay? But maybe one of you will say otherwise. You'll say, no, I think one of you will say, I want to go with the green line. So you'll come with a line that's kind of like this. Okay. And you can see there's an endless amount of lines that we can try and fit to this data. But the thing is, we want to actually know which line best fits the data. And what we mean by best is ideally, if you had, okay, so let's say ideally you had points like this. Try and, oops. All right, let's put a line like this. Let's say we had a line like that. And let's say it was the points or the data were such that every single data point is on that line like this. Then there is no argument that this green line is the best line, okay, because it touches every single data point. But here on this graph, you can see the blue dots don't exactly follow a perfectly straight line, all right? So we need to decide which line do we use to actually fit that data. Now, how we determine that best fit line is by using these two equations here, 1 and 2. Now, what characterizes a line? Okay, there are two basically characteristics that make a line different from one another. That is the slope and the intercept. Okay, so what I mean by that is, here's your horizontal axis. Okay, this is your x, this is your y. Right. Now, what characterizes this green line here that we have is your intercept. So the equation of a line is this: y equals mx plus c. So those two characteristics I'm talking about is this m and this c. All right. So I'm just going to change the color now, or blue to right. But right, it's these two values. So for instance, this green line that you have here, what I'm showing here on this graph, its m value could be, for instance, 2.8. For instance, I'm just thumb sucking values here. That could be the m value, right? And its c value, this intercept, right, could be, let's say, 370. That would be its c value for the green line. But for the red line, it would have a different m value. The red line, for instance, could have 3 as m, and for its intercept, it would have about 350. So you can see that's what makes these lines different. It's the gradient, the slope, and the intercept. All right, now, and these equations that I'm pointing out to here, these equations give you that slope and the intercept. It's just that instead of calling it m and c, for this module, we call it a and b. So b is actually your intercept, and then sorry, b is your slope, and a is your intercept, right? That's what these equations tell you. If you use these equations, you can find the slope of the line, which is b, and you can find its intercept. All right. Does everyone understand that, what I just explained? I'll go through the calculations of how to use these equations, but I'm just going to explain what the slope and the intercept of a line actually mean. Or do you want me to just go back and explain that? Everyone good? Okay. Is A and B the same as B1? Yes, Adrian, that's the same thing, yes. A and B are the same thing as B1 and B0, yeah. So you'll see in your formula sheet, sometimes in your formula sheet, this could be, instead of A, you'd have B0. This could be B0 instead of A, and instead of B, you could have B1. But there's a reason why I'm calling it A and B, is because your calculator calls it A and B, not B0 and, sorry, yeah, not B0 and B1. Although your formula sheet will say B1, you just need to know it's the same thing as B, right? But I'm showing you as A and B because your calculator is going to show you as A and B. All right, so now that we know this, we're going to find the equation of this line, the best fit line, right? And another name for the best fit line is the line of least squares. Okay, so in order to do it, do you have a question? No question. All right, in order to do it, do you think in the exam it will be A and B or B0 and B1? Okay, Alicia, it depends on the formula sheet. It could be A and B, or it could be B naught and B1. Let me just check if I can get a formula sheet now from the past. Just give me a second. There we go. Can you see the formula sheet? If you look here, you can see it is given as B1, but it also tells you B1 is B. Okay, and then B naught is equal to A equals to that. This was a past formula sheet. It's likely they're going to be the same, but if not, just remember that B naught is your intercept and B1 is the slope. Krisha, does that answer your question? Cool, no worries. All right. Okay, cool. So now we're going to proceed to actually working out the equation. But before we do that, okay, we need to identify what is your x and what is your y. Because if you look at this table, okay, so you look at what's given to us. Let's just say these first three columns are given to us. That's all that's given. You need to figure out which column is your x and which column is your y. Now, x is known as your independent variable, okay? So that's your independent, okay? And your y is your dependent variable. Okay, I'll be with you in a second. Y experience, so that's what you're saying, okay. No, okay, good try, all right. So this is how you need to figure it out, okay? If you weren't given this graph, okay, like what I've shown you, if you're not given this graph and you're only given these three columns, all right, look at what affects the other variable. So what I'm saying is, look, if you say you're interviewed, right? If you're interviewed for a job, right, and they ask you how much of experience do you have, all right? So if you say you have about 6 years of experience, then that would affect the salary that you would be offered. It wouldn't be the other way around. Okay, your salary doesn't affect your years experience. So whichever one affects the other variables. In our case, experience affects your salary. So that's your independent. Okay, so your X is actually your experience. Your salary will be your Y. Okay, does that make sense? X is on the horizontal. Right. Yes, but Adrian, remember, you're right. The X is on the horizontal axis, but if you may not be given the graph. So let's say you weren't given the graph and you were only given this, right? So if you didn't construct the graph, or if it wasn't presented to you, you need to figure it out looking at the data. Make sense, everyone? Cool, fantastic. Well done, everyone. So here, this is your experience. It's X, and your Y is your dependent variable, which is your annual salary. All right. Okay, so now that we know that's our X and our Y, all right, there's values that you need to compute for these equations. If you can look at these equations, you can see there's sum xy. Sum xy is a symbol here, sum sigma xy. Right, and there's sum x. You need to get sum x. Then you need to get sum y. And you can see all of the stuff that you need from this equation, sum x squared, etc. All right, so that's what these other columns here are. This is the ones that you need to compute. All right, so the first things first is work with the columns that you have so far. Right, you've given your x and y column, so all you need to do is insert the totals in the bottom. The totals, remember, are the same thing as your sigma, your sum. So if you add up all your x values, 52, 63, 67, etc., you'll get 472. If you add up all your y values, 381 all the way to 610, you'll get 3,550, right? So you'll have your sum of x there and your sum of y there done, all right? Then you need to create your xy column, right? Your xy means you take your x value and you multiply it by y, x times y. If you do that, So for the first row, it's 52 times 381, and then you get 19,812. That's how you get your first value. And you do that for every value going down, all right? And then you total it, and then you get this value is 243,000, right? So your sum xy, that is this value here, 243,305. All right. Then we're going to work out your x squared column. Okay, because if you look at this equation, you can see it's asking for x squared. So this column here is your x raised to the power 2x squared. So all you need to do is you take the first x value, which is 52 here, right? Take this 52 and you raise it to the power 2, and you'll get this value here, 2704. And you do that for every row. So the next value will be 63. You raise it to the power 2, and you get 3969, etc. You do it for all of them, all right? And then you get the total on the bottom. You add them up, all right? And that'll be your sum x squared. Sum x to the power 2. All right. So far so good. All right. The last column is your sum of your y squared. All right. You notice that this equation doesn't ask for it. Okay, this equation here, it doesn't ask for it, but we're going to use it later. We're going to use it for the correlation coefficient. So we're just going to do it now, but I'll get to it later. Okay, so this is your y squared. You do it exactly like how you did the column before, except you take your y values and you raise it to the power 2. So it's going to be 381. This is your first y value, raised to the power 2, and you'll get this value here, 145,161. You do that for all of them, and then in the bottom you total it, and this will be your sum. That's this pin, right? Sum y to the power 2. All right, that's how you get your totals. All right, I'm just going to pause there for a second. Does everyone understand how to get each of these columns and then how to get the totals in the bottom? But I'll show you in your calculator. It's going to be very easy to do it. Everyone good? All right. Okay, fantastic. Now we're going to do it with your calculator, but using the regression function. Okay, so everyone have your calculator with you? All right, so switch it on. All right, so what we're going to do is we're going to use the regression function. So how to do that is you're going to press mode, right? You're going to choose the option stats, right? My calculator is option 2, and then you're going to see an option like this, which in my calculator is option 2. It says A plus B X, and that is why I wrote the equations as A and B, okay? Because your calculator knows it as A and B, right? So whatever that option is in your calculator, A plus BX, that's what you're going to choose. So you choose that option, and then you'll see a column with X and Y. And that is why it was vitally important to identify which is your X column and which is your Y column from your data. And we've done that. This is your X, that's your Y. You can ignore the frequency column, okay? Don't worry about that. So what you're going to do is you're going to capture these X values in the X column, all right? 52, 63, etc. And then you're going to capture the Y values, which is 381, 442, all the way to 610. So if you can do that for me, and just give me a heads up in the chat once you finish capturing them. You should have 7 data points for X and 7 for Y. Okay, give that a go. If anyone's not following or confused about anything, please do let me know. I think some of you have already finished. Nicely done. We'll check the chat now. Fantastic. All right. Okay, so I just assume everyone's done. So we're back here. All right. Once you've captured all of that, you can press the on button if you want. Just do not press mode, okay? You can press your on, you can press the AC button, the data will still be there. All right. Now, if you want to get these sums, so say you wanted sum of x, all right? So instead of actually going and adding, putting 52 plus 63 plus 67, etc., if you wanted sum x, okay, how to get that is you're going to press shift in your calculator, press the button 1, and then you'll see the option sum. That's what you're going to choose because that's what the symbol is, sum. You choose that, and then you'll see all your summations are there. You'll see your sum x is there. So if you want that value, just choose whatever option it is. So my calculator is option 2. So if you select that option and then hit equals to, you'll see you'll get the same total you got here. If you didn't, then you didn't capture the data correctly. You must have made a mistake somewhere. See, so that's how easy it is to get the sum values. Okay, you're going to get that. So if you wanted, let's say I wanted sum x squared. Can someone get me sum x squared from your calculator? Let's see if you know what to do. So it's the same thing. Same approach. Let's see if you remember. What value do you get? So the sum x to the power 2. Yes, fantastic. Well done. 32252. All right. And that's how easy it is to get all the sum values from your calculator. All right. Now, I'm going to show you a long method and a short method to work out the intercept. Sorry, the slope. Okay, your B1. I'm going to erase this. Okay, the long method and the short method. So let me do the long method first, because if they often they'll give you just 3 marks to get the slope. So we're going to work out the slope, or your gradient. In other words, the slope is gradient. Okay, so if you want to work out the slope, that is our B1, or aka B. All right, and to do that, we would use this equation here. Okay, so all we're doing is we're going to follow this equation. All right, and you can see the equation. We can get all the values that's needed for it. Okay, you need your n, sum xy, sum x, sum y. All right, and then you're going to divide it by everything in the bottom. So if it was 3 marks, you need to show the examiner that you've put in all the values into the equation. All right, so what you would do is you'd start entering all the values into the calculator. Now, remember, I've done all the values for you, okay, all the summation values. But if you wanted, you can also just find it from your calculator, like how I just showed you now. So the first value in the calculator is n, and n is the number of data points. So how many people here are in this table? As I said earlier, there's 7 data points. So your n is 7. So I'll just write it here somewhere. Your n is 7. Okay. All right. So I'm just gonna follow. All I'm doing now is I'm following this equation here. I'm following this equation. This equation here to find out slope. So 7, which is your n value. The next value that you'll see is this sum xy. That sum xy value is 243, 305. All right. Minus, then the next thing we need to put in is the sum x. Sum x is 472 from our table. It's 472 times sum y. So sum y is 3550. Okay. 0. Okay, and then we're going to divide that. Now we're going to go to the denominator, everything in the bottom. The first value there is your n, which is 7 into sum x squared. Sum x squared is this value here in your table, 32252, which you've also put in the chat. 32252. All right, minus sum. Now this part is not the same as this. It's not the same. This is telling you to square the x first and then add it up. This is telling you to sum up the x first and then square it. So it's telling you to take this value, this sum x here, and then you square it. Make sure you understand the difference. Okay, that's why it's got the brackets around the sum x. It's 472 all squared. Now, if you plug it into your calculator, you should get a value of 9.24, rounded to 2 decimal places, 9.24. Okay, and we expect to get a positive value because if you look at our data, it's sloping upwards. Let me just check the chat. No, Kai, you must have made a mistake. And I'll show you how to double check your answer, right? This is how you can sense check your answer. Now, I've shown you the long way to work this out. Okay, this is the long way to work this out. Now, the shortcut is you can actually just pull this value from your calculator. All right, and how you do that is you'll press Shift 1, right, and then you'll see the option VAR, variables. Okay, you'll select that option VAR, and then, oh no, sorry, ignore what I just said, sorry, just press on in your calculator, press on, my bad, press on, press Shift 1, and then choose the option REG, regression. Choose the option REG, okay? If you select that, then you'll see B is there. In my calculator, B is option 2. So select that and then press equals to, and what value do you get? You should get the same thing I have here, rounded to 2 decimal places. Everyone? Anyone didn't get that answer using the method I just explained on your calculator? People, did I lose you? Would you want me to repeat that? Same. Oh, okay. Right, okay. It's just good that you identify where your mistake was. Okay, so does everyone, let's see, let's put the same. Everyone got 9.24, right? Okay. So everyone understands how the shortcut works. The shortcut is just to go straight to your calculator and go to the regression option and pull out your B. But this is the long way. If you were getting 3 marks for getting the slope, this is the method you need to do. You need to show the long method. But if you're getting only 1 mark for it, then just do the shortcut with the calculator. Okay, just make sure you understand that. Right? Use the mark scheme to guide you. All right. Now that you've done the slope, the next step is to get the intercept, which is the A value. Now you could do the shortcut method. Let's see if you can figure that out. Okay, I've showed you the shortcut to work out B. All right, the slope. I want you to try and give it a bash to try and get the A now, and write it on the chat. So now I want the intercept. I want the A. Okay, so remember, try and figure out how to get to the REG option in your calculator. Regression. I'll give you a minute. It's really quick to get it, but I don't get any answers. I'm going to guess that you're struggling. Arjun, you shouldn't. You wouldn't have lost it. The only way you'd lose the data is if you press the mode button. If you want to check that the data is still there, press Shift 1, and you'll see the option that says data. And if you press that, you'll see that your data is still there. As long as you didn't press the mode button, your data should still be there. Okay. So what I want you to do is now to get the A value. Tell me what the A value, the intercept is. 677? No. Oh, okay, that's why you pressed the mode button. Okay, let's all of us get the A together, all right? Okay, what we're going to do is we're going to press Shift 1, and then we're going to choose REG, regression. And then you'll see the option A, which is number 1. on your calculator. It should be the option number 1. We're looking for A. Where you see that, choose that if it's option 1 plus 1, and then hit equals to. And everyone should get minus 115.89. Let me know in the chat who got this value. A is minus 115.89. Right. Okay, does anyone want me to explain again how to pull the A value from your calculator? Okay, you need to let me know in the chat. If you want me to just explain how to get the A from the calculator, just give me a heads up in the chat. Just say, please explain, and I'll go back to that. Because I'm not sure if you know how to get the A, but you're getting a different value, or you're just not sure how to get the A from your calculator. You guys need to let me know. Subangila, are you good? Are you able to access the A, but you're just getting a different value? Oh, you have to fix your data. Oh, okay. All right. Okay. Okay, so that's the shortcut, okay? All right, that's the shortcut to get A. You can use it to double check your answer. No problem, no problem. Let's do A using the long method. All right, so that means now we've got to use this equation. It's very easy. You just plug the values into the formula, right? The long method, so we're going to get A now. Let's just intercept. Okay. Right. So now we're going to use the formula to get the intercept, right? Which is this formula here. Okay, we're going to use this formula here to get A. So we're going to use that formula. The new first value is sum Y. In our table, it's 3550. Okay, so that's the first value I'm using. This here, sum Y. Minus B, which is what you worked out earlier, which is 9.24. Yeah, minus 9.24. Right, into, so there's your B, 9.24, times sum X, which is 472, I believe. Right, all divided by N, which is 7. And if you work that out, you'll get the same thing I did earlier, which is using the shortcut, which is about minus 115.89. Close enough. If you did, it's the rounding is different, but this is what you should get, something very close to that. So that's the long method. That's your intercept, your A. All right. So the equation of the line, okay, the equation of the line is this. It's Y equals B1x, that's your slope, B1x, plus B naught. So you need to write the values out that you found for B1. B1 is 9.24 x plus your B naught, which is the A, which is the same thing, is minus 115.89. So you can write it like this in bracket, minus 115.89. All right. Now, there's one more thing you need to state here when you write this equation out, okay? Now, remember, I'll explain this in a second as to why this is important, okay? So this line is only valid for this domain. What I mean by domain is these limits of x values. So the lowest x value you got is 52, and the highest x value is 77, all right? So you would say for the lowest value of x, which is 52, and you write it like this mathematically, 52 less than x, less than the highest value, which is 77. And let me explain why this is important, okay? Now, in practice, what happens is this. You're fitting a straight line to some data points, right? So here, is your graph. You've got your vertical axis, you've got your horizontal axis, x, your y, right? Now let's say you were given these data points, like what you have in the graph on the top, right? So here, it's kind of straight. So it's safe to put a straight line, all right? But after that, you don't know what the data points would look like. You don't. So for instance, this example here, Ethan's salary is the highest, it's 77. But out there in that company or in the real world, there may be other people whose salaries are quite different. So it starts going higher, but it's a different pattern. It starts going higher like this. Now, if you can see that if I continue with the straight line, it's not going to fit that other data, this new data that we have. It's very far off because after that, it could be following some other mathematical pattern like this. So that is why we can only say that this line is reliable for the data points that we have in this table. And that is from 52 all the way to 77. All right. Does that make sense, everyone? Which is why we need to write this here. We have to say what domain or what limits of x that this line is valid for. Let me check the chat. Makes sense. All right. Now, remember what I said earlier, right? This is all about predictions, and you know, I know we did so much, and we didn't talk about predictions. How does that actually come in? Okay, now all of that hard work and this mathematics to get this equation was to enable us to do predictions. Now that we've got this equation, okay, now that you've got this equation, you can use this equation to make predictions, all right? And I'll show you how. Now, the thing about an equation of a line is that if you feed any x value into this equation, right? So for instance, look at this equation, right? You know what your B1, you know what your B1 is, and you know what your B0 is. There it is here, 9.24 and this minus 115. We know these values. The only value that changes is your x. So whatever x value you feed into this equation, you will get a y value out. Now what that's actually doing is it's telling you if you feed in any months of experience value into this equation, if you feed any months of experience into it, out will come a annual salary amount. That's how the prediction comes into effect. Okay, so for instance, let's say someone with a months of experience value of 68, right? So someone says, I have 68 months of experience. So your X value is 68, right? And then using that equation, you can estimate what their salary should be. Okay, so you can see how effective this is. All right, so someone says, I have 68 months of experience. Instead of thumb sucking a value of what the salary you should offer this person is, you could use this equation. So what you would do is you'd plug 68 into this equation. All right, so that would be, now you get your B1, so you plug it in, you'll get 9.24 into your X value, which is the 68, minus 115.89. All I'm doing is I'm feeding this into this equation and working it out. So you can give this a try in your calculator. Okay, plug it into your calculator and write the answer in the chat. It's 9.24 times 68 minus 115. What do you get? Yes, yes. Everyone's following? I hope so. Please, if you're not, if you're confused about anything, please do let me know. The value you should get is 512.42. Okay, 0.42. So let me see the chat. Yeah, close enough. 43 is still fine. You're still correct. You're not going to get penalized for that. Okay, so 43. Let's make it 43 like everyone, but it's not a big deal. Now what we're gonna do is remember, don't forget this, okay? Your salary, your Y value, it's in thousands, okay? So this first value for Jill, who's got 381, she makes 381,000 per year. So the value you got here, it's not yet the full value. You still need to express it in thousands. So this person that came in with 68 months of experience, if when you estimate the y value, it's 512.43. So you still need to convert it to the full amount. And to do that, you just multiply it by 1,000. Okay, so it'll be 512. Let me just get this pen to work. Pretty easy to just multiply by 1,000. You say 512.43 times 1,000, which gives you 430. So what we're saying is, okay, you have 68 months of experience, so your estimated annual salary is 512,430 rands. Okay, does everyone understand how to make a prediction using this equation? Does it make sense to you? You feed in your x value, and out will come your y value, and you just need to express it in the units in your table. Fantastic, fantastic. So this is okay. So what we've done here, this is using regression to make predictions, and this is commonly used in the real world. And this is just a few data points. This is just 7 data points. But in the real world, you work with a large number of data. So you won't actually be using your calculator like what we did here. It's just some information for you. You're not going to be tested on this. But just to give you an idea, in the real world, you would actually use programs or software or Excel to actually do this work for you. So it makes it a lot easier. Excuse me, it makes it a lot easier for you. But obviously for the exam and the assignment, you need to know how to do it using your calculator, just to show that you understand how to do it. All right, so that's getting the line of best fit or the least squares line. All right, now there's still a little bit more that I need to cover, and that is the correlation coefficient and your R squared. All right, but it's not a big deal. All right, it's pretty simple. So let's get there. So one of the questions you could be asked is to calculate the correlation coefficient, all right? Or in other words, it's your R value. That's your correlation coefficient. So if they ask you to work with your correlation coefficient, you need to work with your R value. Now to work with the R value, it's this equation here, right? But I wouldn't encourage you to actually start feeding in the values into the equation. You can use the shortcut to do it, all right? Because it's quite messy using the equation. And the shortcut is just to use your calculator to pull this value. All right? So say you wanted your R value. What you're going to do with your calculator is you're going to press Shift 1. And again, you're going to choose the option regression REG. If you do that, you'll see R is there. So you'll select that and get a value. Can you write that value in the chat, just so I know that everyone's on the same page? What value do you get? Very good. Yep. That's close to point, it's, yeah, 0.9496. So let's just make it 0.95, okay? 0.95. Now, what does this value tell us? Okay, what does this number tell us? Now, what this number tells us is, see the chat? Sorry, I had it. Oh, no worries. Okay, so if the value is above 0.9 or above 90%, if it's above, fantastic. I'm glad that everyone's getting the same value, right? So we're all on the same page. So if you get a value of 0.9 and above, that's saying that it's a very strong correlation, right? So the value itself, 0.9 and above, is telling you it's strong, very strong, I would say. Okay, so it's very strong. Now, what does it actually tell you? Now, this is what it tells you. Say I could have some data like this, where the points are like this. Okay, so what it's telling you is that it's almost random. So and this is your y-axis, this is your x-axis. Now what it's saying is, if I had to draw a line that will kind of fit this data point, it's saying that y is constant. Look at the y is not going up, neither is it going down. It's almost a straight line. So it's unaffected by x. You could be increasing your x going this way. You're increasing your x as you go this way, but your y is not being changed. So what we're saying is x has almost no effect on y. And when that's the case, then there's no correlation. Your R is 0. Okay. That's what the zero means. There's almost no correlation, right, between X and Y. However, if the data points are such that it's like this, so let me erase this. I know it's going to become too cluttered. Take that out. Let's say now the data points are like this. So here you can see a pattern, because as your X is increasing, so that means as you go this way, as your X increases, your Y is going down. It's decreasing. So when your X increases, your Y decreases. So that's a negative correlation. This is negative. Here you could have a value of, for instance, R equals minus 0, minus 0.8, say. Let's just say that. So that's what a negative value for R means. It means it's negatively correlated. Now, in this example that I've shown you for this table, as someone's month experience increases, you expect the salary to increase. So that's a positive correlation. Hence, why we got a positive value. Can anyone think of a real world example where if your X increases, your Y decreases? Just think of something. There must be something that you can think of where if your X starts to decrease, then your Y, I'm sorry, if your X starts to increase, your Y will decrease. Let me give you an example, all right? Let's say your X was the amount of time you spent exercising, and Y was your weight. So the more you exercise, all right, the more likely your weight is to decrease. So you're increasing the time that you spend exercising, and your weight will decrease. That's kind of a very simplified example. Does that make sense? Price of fuel and fuel put. Yes. Very good, Adrian. Yeah. Okay. If the price of fuel increases, then the demand of it would decrease, okay, because it's becoming too expensive. Very good example. Right? You can, and I'm sure all of you can think of a lot of examples where that is the case, and then you will have a negative correlation. Okay, so in your textbook will give you the range of what is constituted as strong for correlation. So I'm just reiterating here, anything from 0.9 and above is very strong, all right? From 0.7 to 0.8, it's strong, and then between 0.4 and 0.6, it's about moderate. Anything lower than that is weak. Now, how you interpret this correlation? So we got a value of 0.95, so you must state this, okay? I'll write this in text here. You need to say very strong positive correlation. That's what you need to state. So you don't just give the value like what I've done, okay? You must interpret it like what I've written here. Very strong positive correlation. All right, does everyone understand that? Everyone good with that? People? Thanks, Saurabh. Thank you for the feedback. All right, and the last thing we're going to finish off with is, and we're at the end now, so the last thing we're going to finish off with is the R squared value. Okay, the R squared value, as the name suggests, R squared is you take the R value and you raise it to the power 2, and then you write it as a percent. So what you're going to do is you're going to take this 0.95, and we're going to raise it to the power 2. I'll get to the chat now. And then we must express it as a percent. But the downward slope close to -1 will be very, that's right, Adrian, yes. If you get close to -1, so for example, if your R was minus, hypothetically, 0.98, let's say this was your R value, then you would say very strong negative correlation. Yeah. So let's get back to this. Your R squared Okay, you take 0.95, you raise it to power 2, and you express it as a percent. It's about 89.7%, roundabout 89.7%. Your answer may be different because of the rounding. Let's see what you got. Maybe I'm wrong. Sorry, let me do it in my calculator. So 0.95 raised to the power 2. Yeah, you're right, everyone. That's because I've got too many decimals on my workbook. Thank you. So let's go with 90.25%. 90.25%. Well done, everyone. Well done. Remember to say percent. Okay, people, remember to say percent, okay? Don't leave it as 90.25. Now, let's interpret this. Okay, so r squared, there's a special name for this r squared. We call it the coefficient of determination. Okay, remember that, because in the test or the exam or assignment, they could ask you to work out the coefficient of determination. You need to know that that is the same thing as r squared. Okay, remember that, coefficient of determination. Now, what this actually means, okay, well, what does 90.25% means? All right, let me get some space on the board here to kind of express this or explain it. Right, so just like before, I had my x and the y axis here, right? If your data strongly predicts, so if your x value, in our case, it's your month experience. If your month experience has a very strong correlation with your y value, okay, it'll be like this. This will be, let me put the straight line in a different color. Okay, you're going to have this kind of relationship here. Now, this is telling you that when these points are close to the line and you can see there's a slope, whether it's positive or negative, doesn't matter. It's showing you that your x value is very good at predicting your y value. And this r squared tells you basically how much of the variation of your y can be explained by your x value. If the value is 90% and above, it's quite strong. So that's telling you that your months of experience, in other words, your x, okay, your months of experience explains 90.25% of your annual salary. Okay, let me write that down. This is how you would interpret it. You interpret it as your months of experience. So I'll write months of experience. And I'm just going to put brackets in x, but you don't need to write the x. What you do need to say is what your x is. In other words, your months of experience. So you would say your months of experience explains 90.25% of your annual salary. That's it, and that's your y. So I'm just writing your x and y so you know which is the x and y. But this is how you'd explain it. So can't express this enough. I've seen this in many exams and assignments. Students just say x explains 90.25% of y. Okay, and you're not going to get marked correct for that because you can't give a general answer. You need to show the examiner that you know what the x is and what the y is. So you would say your months of experience, which is your x, explains 90.25%. Sorry, I forgot to say something. I forgot to say something else. It's not 90.25 of your annual salary. It's 90.25% of the variation of your annual salary. Sorry, this is what it should be. Check the chat now. I think I've got a question. So the prediction for a salary based on the number of months. No. Adrian, no. It doesn't have to do with accuracy. Okay. Yeah, it doesn't have to do with accuracy. I think what you're saying here is more about accuracy. That's not it. It just says that as the variation in your y, the change in your y, okay, that means the higher this value is, this r value, right, this r squared. So the higher this value is, okay, it's telling you that if you change y just I mean, if you change x just a little bit, it has a significant change in your y. That means your y is very sensitive to your x. If, for instance, your r squared, let me put a different color here as an example, hypothetically, let's say hypothetically r squared is uh, 20%, 20%. Okay, then what happens is if you change your x, it's not going to change your y as much as compared to this. Okay, so here your y is very sensitive to a change in x, whereas here the y is not sensitive to a change in x. That's why we say variation. So we say months of experience explains about 90% of the variation of your annual salary. Does that make sense, everyone? Is anything unclear on that? Happy to explain it again in a different way. Okay. All right. So that is it for this learning unit. Um, I'm hoping all of this made sense to you. And yeah, these are all the key points that I wanted to cover. Also shows that. Yes, Kalisha. Yes, that's right. The graph does show that. Yes, exactly. All right. That's it from my side for this evening. Um, let's see if there's any questions. You're welcome, everyone. All right. I hope you enjoyed the session. I hope it made sense to you. Um, yeah, I will provide an exercise for you to work through. Um, and if you, I would encourage you to watch this code app again, uh, just one more time to kind of consolidate your work. And that's it from me for this evening. No questions now. Fantastic. Made it a lot easier than before. Okay, I'm glad. I'm very happy to hear that. Very happy. Uh, and marking is not great because I haven't started yet, but I will get to it. uh, Thanks for reminding me. I have a busy week ahead. All right, all. Do enjoy your evening, and we'll chat soon.